everyone, this is me Shweta Biswas. Welcome back to my channel dedicated to my juniors. So here we were discussing about the entire full portion revision, right? So of 9th grade. So now we stopped at quadrilaterals. I finished explaining that. Now we're coming to circles, right? We're coming to why do I keep getting this wrong? Yes, we're coming to circles. Circles. We're coming to circles. Okay. So, angles. Okay, we have this angle subtended theorem by a circle. So, what happens is that if this is a circle, and this is a chord, or you can say it's an arc. Okay, and it is subtended to the, and this is the center. Okay, so the angle subtended by this chord to the center will always be double than what it is being subtended to any point on the circle. For example, it's subtended here, or it's subtended here, or chai subtended here, anywhere. If this angle subtended to the center, if this is 70 degrees, here it will be 35 degrees, here also it will be 35 degrees, here also it will be 35 degrees. No matter what you do, it will be 35 degrees. Always half. Okay, so this was the angle subtended theorem. Okay, then we have other theorems as well. Let me try to remember and tell you. Okay, if this was a circle, okay, and if this was the diameter of the circle, okay, this is the point O, center, okay, center. Now this angle subtended by these 2 points by the diameter, okay, by A and this is B, let's say. Okay, angle subtended here, let's say at this point O dash, okay, O dash. So angle A O dash B should be equal to 90 degree, okay, because it's an angle subtended by a semicircle. Basically, the circle, when it is divided by the diameter divides the circle into 2 equal halves, and each equal half is called a semicircle. So the angle subtended by a semicircle is always 90 degree, always a right angle. Okay, this is the angle subtended by a semicircle. Then yes, equal chords subtend equal angles at the center. Okay, let's take this as a circle. Okay, let's say this is one chord, this is another chord, this is center O. So the angle subtended, okay, let's say this is a chord AB, this is chord CD. Okay, so angle subtended here, and this is center O, angle subtended here. So angle AOB is equal to angle COD. This is given. Angle AOB is equal to angle COD. So from here we can infer that AB should be equal to CD. The chords are same. Okay. Why? Because the angle subtended to the center is same. That means the chords are same. Okay. As far as you remember, okay, one more I know. So one second. Yeah. Okay. If this was a circle, and if there is a quadrilateral inscribed into it, cyclic quadrilateral, when it's being inscribed into the circle, it's called a cyclic quadrilateral. Okay, so here let's say this is A, B, C, D. Okay, so angle A plus angle C should be equal to 180 degree, and angle B plus angle D should be equal to 180 degree. This is a property of a cyclic quadrilateral. It means opposite angles will be supplementary. Okay, this is the property of a cyclic quadrilateral. Okay, so this is the end of our chapter, circles. Okay, now we have Heron's formula. So what happens in Heron's formula is that Heron's formula, yes, we have formulas. Yes, we have formulas. We need to remember, of course. Okay, this was chapter 10. Yeah, chapter 10. Let's go. I'll take green font. It's pretty. Okay, chapter 10. Heron's formula. So basically, what we do here in Heron's formula, we're trying to find the area of a triangle whose sides are all differs. All the sides are different. For example, this triangle A, okay, like this. Sides are okay. Triangles ABC. Okay, here each side. Okay, let's just give it as ABC. So now, how do you find the area of this triangle? We find as AB plus BC plus CA. Easy. This is the perimeter of this figure, of this triangle, right? But you need to find the semi-perimeter. What is semi-perimeter? Means basically the perimeter by 2. Perimeter we know it's AB plus BC plus CA. So semi-perimeter is this by 2. This is the semi-perimeter denoted by letter S. Okay, this is semi-perimeter. After you find the semi-perimeter, you can use it to find the area of the triangle. How? Area is equal to root S into S minus A, S minus B, S minus C. Here we can say it is root S into S minus AB. AB basically this side. Okay, this side. Okay, you know what? Instead, let me just say this is A, this is B, and this is C. That's much better now, na? So in that case, let me write this properly for you. Semi-perimeter, semi-perimeter, S is equal to A plus B plus C by 2. So area is equal to root S into S minus A into S minus B into S minus C. Clear? Crystal clear, right? This is the area. This is area of a triangle whose three sides are unknown or they are differing. Okay. Now, in case, if it's a right angle triangle, our favorite formula we've been using since grade 7, I guess, right? So this is the this is the formula we use for a right angle triangle. We use half into base into height, right? That is here, let's say, okay, this is A, this is B, C. Let's not write, make our life difficult. So half into A, B. Okay, this is the area of a right angle triangle. Now, what's the area of a equilateral triangle where all the sides are same? Okay, A, B, C, let's say, and all the sides are A, A, A. How do we find this? Equilateral. Wait, let me put some signs so that it will be easier for you to differentiate. That's the new topic. Okay, equilateral triangle. Triangle, it is root 3a square by 4. This is the area of a equilateral triangle. So these are all the three formulas you need to remember. Among them, this is the Heron's formula and everything else is the triangles formula. Okay, so this is chapter 10. We are done with Heron's formula. Now let's move on. Okay, surface area and volumes. Yes, this also has lots of formulas in it. You need to remember them. These are very important as well. Okay, where did that thing go? Oh, why does the grid keeps going? I don't want this. I want this. Yeah, better. Okay, stay there now. Okay, stay. Okay, I'll take color. Any, mini, many more. Black, or black. Okay. Oh, I took highlighter. Okay, now better. Stick black. Arey, black, aja. Okay. So, what were we doing? Yeah. Chapter 11, na? Chapter 11, we have surface area and volumes. Okay. So, first of all, let's start with a cone. A cone looks like this. This is how a cone looks like. Some important things related to cones. Okay. So, there's this thing which goes all the way from the tip of the cone over here till the center of the circle. You know, this thingy is basically the circle. So the center of that circle till that center, that is called the height of the cone. Okay, H, it's denoted by letter H. Then, oh my god, what did I do? Oh my gosh, help me somebody. I had to cut it off. My pretty drawing. Okay, this is H, then from this center to one point of the circle, what is that called? That is the radius of the circle, right? This is R, right? Then what about this one? This is called the slant height. It is denoted by letter S. See, slant height and height is not the same thing. Height is basically the perpendicular distance, okay, and slant height is the hypotenuse. If we make this into a right angle triangle, if we draw it again like this, this is the H, this is the R, this is the L. You can see the L is obviously greater than H and R because we know hypotenuse is the longest side of a right angle triangle, right? So how do we find L actually? We know L square is equal to H square plus R square according to Pythagoras theorem, right? So L is equal to root H square plus R square. Okay, this is one thing about cones you need to know. Okay. Now, one important thing. Let me draw this thing for you. This will be very, very helpful. I'm telling you. Cone. Let me write here cone. Let me write here sphere. H-E-R-E. And here I'll write hemisphere. Okay. we used to have, as far as I believe, we used to have cylinders as well, but that's now a deleted portion, so we are lucky we don't have it. Okay, let's make a proper thing. Okay, whatever. And this. Okay, 1, 2, 3. First thing, we'll know the total surface area, TSA. Then we'll know the curved surface area, CSA, or LSA. See, there's no difference here. You can't say the word CSA, curved surface area, for a cone, because the cone doesn't have a curve. Okay, it's lateral surface area. It's basically like lateral, like straight line. Nah? Straight line, you can say, almost straight. It's not curved like as that of a hemisphere or a sphere, right? So that's why. Then, and we know volume. We need to find all these things. So in a cone, what's the TSA? TSA is equal to pi r into r plus L. Okay, and then the LSA for a cone is pi r L. Okay, and the volume is 1 by 3 pi r square h. Okay, now for a sphere, what's a TSA? Sphere TSA is what's a TSA? Okay, 4 pi r square. Okay, this is the TSA. Now sphere, obviously it does not have a curved surface area, because it's a curved everywhere. It's completely curved. Nah? So that's why it does not have this thing. So I'll just cut it off, strike it off. Okay, then volume of a sphere. What's the volume of a sphere? Volume of a sphere is nothing but 4 by 3 pi r cube. Okay, now hemisphere TSA is 3 pi r square. Then the curved surface area is 2 pi r square. Okay, and then the volume of the hemisphere is 2 by 3 pi r cube. Clear? This thing should be in your blood. Okay, you should be very thorough with this thing. Okay, so this was curved surface area and volumes. We just have one more thing left. Okay, statistics. Oh, statistics, we don't have anything in statistics. There are no formulas there. All you need to know is a graphical representation of data. Bar graphs, pie charts. What else? Bar graphs, pie charts. So we don't have pie charts. Okay, bar graphs, histograms, and frequency polygons. Okay, these are how you have to mention. And yes, that's it. That's our entire portion for 9th grade, and we have finished it. Good job. Okay, so I think that's going to be enough for today. Well, meet you in my next video. Okay, bye. Stay safe, stay happy and healthy. Bye.